section 3. So section 3 we started logarithmic functions and how to change them from logarithmic to exponential. Today we're going to go over how to graph a logarithmic function. Okay, so make sure you have that note sheet out in front of you. So the function y equals log base b of x, where b cannot equal 1, is called a logarithmic function. The graph of f of x equals log base b of x represents a parent graph of the logarithmic functions. So we still have this parent graph happening, so we can use that parent graph to change what, or to translate our logarithmic function as well. So you have an asymptote along the y-axis. Okay, so before in our exponential functions, we had an asymptote along the x-axis. Okay, now we have an asymptote along the y-axis. Okay, so that's this one right here. Now it is fairly easy to find different points for a logarithmic function. So we can just use these three here, and I'm going to highlight them. So we can use 1 over b, comma negative 1. We can use 1, 0, and b, comma negative 1. And we can plot those 3 points, and then we can graph our line. Okay? If b is a fraction, okay, then it's just the opposite. So we still use b, comma 1, 1, 0, and 1 over b, negative 1. Okay? But your graph is just reflected over that x-axis instead. Okay, and you still have an asymptote at the y-axis. Okay, so this is what our logarithmic graph looks like. So going into graphing a logarithmic function, we have 3 steps. So first step is to identify the base. Okay, so we want to identify the base. Your base is this number between the log and the x. Okay, so our base, or b value, is going to be 1/5. Okay, so our base, or b value, is 1/5 in this case. Step 2 is to determine points on the graph. So again, we're going to use those highlighted coordinates that I had from above. So we're going to use 1 over b, comma negative 1. We'll use 1, 0, and b, 1. Okay, so for our graph in particular here, our b value is 1/5. So I just need to plug in 1/5 for b. Okay, so I would have 1 over 1/5, negative 1. What's 1 over 1/5?
5, 2.
It's 5. Okay, so I would have 5, negative 1. Okay, I'm still just going to use 1, 0. Okay, I didn't have a b value to plug in there. And then plugging in b here, I would have 1/5, 1. Okay, so I have 3 points. The last step then is to plot the points and sketch your graph. Oops, I didn't mean plots. Again, I just meant plot points. Got ahead of myself. So plot points and sketch the graph. So I'm going to plot those 3 points, and I'm going to sketch my graph. So I have one at 5, negative 1. I have a point at 1, 0. And a point at 1/5, 1. Okay, and you still have this vertical asymptote along the y-axis, so you don't want to cross that y-axis. Okay, you want to get close to it, but not cross it. Just like when we had exponentials and the x-axis. Okay, so that would be your logarithmic graph. Okay, questions on that one? Using your 3 different points, your b value to plot those points. Fairly easy, yes? Not too bad? Are we good? Yeah? Okay, so on the back then, the same techniques used to transform the graphs of other functions you have studied can be applied to the graphs of logarithmic functions. So again, you have this parent function, and we have an a value, a h value, and a k value. So again, h is your horizontal translation. Okay, that changes your x value. It moves it left or right. K is your vertical translation. It changes your y value. It moves it up and down. And A is your orientation and the shape. So it could stretch it vertically or compress it vertically, okay, depending upon what A is. So looking at my second example here, A would be 3. That's your number in front of your log function. Okay, so A is 3, meaning it's going to be stretched vertically. Okay, and when I stretch something vertically, that means I'm changing the y value. Okay, so here for this one, I would change the y value. Stop, please. Okay, so we're changing the y value if you have an A. H is with our x value in parentheses here. We don't have an h value in this case, so that would be 0. So it's no horizontal shift. Okay, so there's no horizontal shift. If there was, this one you would change x. So you would be changing your x value in this case. Okay, if you did have a horizontal shift, you'd be changing your x value. Okay, then our k value is the one on the outside here. Okay, so that one's 1. Okay, so that means we're going to go up 1 unit. Okay, since I'm moving up, is that going to change y or x? Y. So we're going to change our y value. Okay, so the reason I'm writing these out is because I'm going to show you a different way to get these points. Okay, so just like on the front, I want to use those 3 original coordinates. Okay, so first, what is our base value, our b value? Okay, so b is 10. Okay, that's our base value there, it's 10. So now I can write out those 3 coordinate points. So I'd be at 1 over b, negative 1. Okay, my other one is at 1, 0. And b, 1. Okay, so those are the 3 points that I have, right? So I'm going to plug in 10 for b. So in this one, I would have 1 over 10, negative 1. This one, I don't have to change anything. It just says 1, 0. This one, plug in 10 for B. All right. So now, what I'm going to do, I need to change my Y value and stretch it 3 vertically. Okay? So my Y value here would be -1, 0, and 1. Now, if you have an A value, it's multiplying that Y value. Okay? So to get my change in my coordinate, I'm going to multiply by 3 to each of my Y values. Okay? So that's why I wrote out we're changing Y when I have an A value. Okay, so I'm going to multiply that Y value by 3. So I would have 1/10, -3 now. For this one, if I multiply 3 into 0, it stays at 0. So I have 1, 0. Okay, and this one, if I multiply 3 into 1, I get 3. So I have 10, 3. Okay, I had another change. What was my other change? It was this 1 here, and I have to change Y again. Okay, so I'm not changing any of my X's, but I need to change these Y values. Okay, so now, since I'm going up 1 unit, that means I'm going to add 1 unit to all of my Y values. Okay, so here I would have 1/10. Add 1 to -3, that's -2. Okay, for this one, add 1 to 0, that's 1. For this one here, add 1 to 3, that would be 4. Okay, so now I have my new coordinate points using my translation values from above. Okay, if I had a horizontal shift, okay, that would be adding something on to your X values. So that's why I wrote change your X value under that one. Okay, so if I had a horizontal shift of +1 instead, I would change this to 1 and 1/10. I would change this to 2. I would change this to 11. Okay? So that's what that does when you're shifting your graph. So now that I have my 3 coordinate points here, I can plot those. So I have 1/10, -2. I have 1, 1. And I have 10, 4. Okay. So we still have that vertical asymptote along the y-axis since I didn't shift left or right. So that vertical asymptote is still in that same spot. So we approach the y-axis, but we never cross it. And that would be my logarithmic graph for this function. Okay, questions on how I changed each of those coordinates? Okay, so again, if you have this A value in front, always do that one first. Okay, so after you get your original parent function points, go in order. Okay, so do your A value first. That one you have to multiply in. It's the only one you have to multiply in. And it changes your Y value. Okay, so multiply into your Y value. Then you can do your horizontal shift if you have one. That adds into your X value. Okay, we didn't have one here, so I didn't need to add that in. Your K value changes your Y value. So we add in whatever that number is to your Y values after your stretch. You're vertically stretching it. What? h would be adding 2. Yes. So you'd add that to your x value. Okay, other questions on how I graphed this function?